This is example 4.1.1. It says a boy walks 120 meters at 48 degrees north of west. So when you start to get things like directions, it really helps if you draw the question first before you move on to do the given and so forth. So it says a boy walks 120 meters, and then it says at 48 degrees north of west. So we have 48 degrees, and it says determine how far you can walk west and north to end up in the same location. So I would have to walk west and north. So basically what this question is asking is for the x and y components of this particular vector. So we're trying to solve for x and y, and what we're given is you're given this right here, which is the hypotenuse. Remember, the hypotenuse we actually call r. We're going to call it 120, and we're also given the angle, which is theta, which is 48. So the principle that we're going to use here is we're trying to solve for x and y using this information right here, and our formula is x equals r cosine theta and y equals r sine theta, because cosine is the adjacent over the hypotenuse and sine is the opposite over the hypotenuse. So sine gives us y and cosine gives us x. So if we look here, we can go ahead and plug our numbers in. We can say x is equal to 120 times the cosine of 48, and we can say that y is equal to 120 times the sine of 48. At this point, we just enter it into our calculator. The one thing you need to be careful about is that your calculator is in degree mode. So then we go 120 times the cosine of 48 and 120 times the sine of 48. And when we do that, we get that the cosine is 80.3 meters, and that this one, the sine, is 89.2 meters. So we have 80.3 meters. Since this is the x component, it's west, and 89.2 meters is the y component, which means it's north.